Our next keynote speaker is a voice from the classroom. Kevin Dykema has been a middle school mathematics teacher for 25 years at Mattawan Middle School in Southwest Michigan. He teaches his middle school students to become confident mathematicians every day in his classrooms. As a teacher, he emphasized that doing math is more than getting the answer. It's about real people solving real problems. He is the president of the National Council of Teachers of Mathematics, which has 30,000 members nationwide. Kevin has actively been involved in NCTM and its Michigan chapter throughout his career. He has served on its board of directors and has been the annual conference chair for 6 years. He co-founded an NCTM conference focused on teaching mathematics to students with disabilities. Kevin is a frequent speaker, the co-author of the book Productive Math Struggle, and has written several articles for Mathematics Teacher, Learning and Teaching, PK to 12. He is passionate about mathematics education and loves working with others to improve mathematics education for each and every child. In his classroom and his national leadership, Kevin is a champion for equity. Please welcome Kevin Dykema.
Hi, my name is Kevin Dykema, and I'm the current president for the National Council of Teachers of Mathematics. Prior to this role, I've been an 8th grade mathematics teacher in Southwest Michigan for over 25 years. Today, I want to talk about increasing opportunities for students, and that's such an important thing as we're thinking about mathematics. But first, I wanted to say thank you. Thank you for all that you do in whatever setting that you have to help meet the needs of each and every student. When I think about the National Council of Teachers of Mathematics, I'm always struck by the mission statement. And in that mission statement, you see that each and every student. And that really boils down to opportunities. What are we doing to better meet the needs of every single one of our students? As an early career teacher, I know I used to be happy if, say, 75% of my students did well on a quiz. I'd be like, way to go, Kevin, nice job. But it didn't take me long, and I realized, what about that other 25%? And you can use whatever percent you want other than 75 and 25. We at the National Council of Teachers of Mathematics are advocating, what are we doing to better meet the needs of every single one of our students? And you can find out much more information about our organization there, but I want us to think first, what is mathematics? So I'm going to pause briefly. I want to give you a chance to think about, what would you respond if somebody came up to you and said, hey, describe mathematics. What is mathematics? So thank you for thinking about that. Because I think the way that we respond to this has so many ramifications for how we view mathematics to be taught. If we think that mathematics is purely getting the answer to a problem, then we teach one way. But so often as I work with mathematics educators, they realize that's only a small part of mathematics. Getting the correct answer is an important part, but there's so much more to mathematics. Mathematics, we want to develop the reasoning skills. We want to develop problem-solving skills. We want our students to have a good, solid understanding of the mathematics, not just memorized algorithms, but what is that algorithm telling us? How are we doing? Maybe we're developing those algorithms. And when we view mathematics as more than answer getting, when we view mathematics as that deep problem solving, that deep understanding, that making sense of the world, we need to teach mathematics differently than if we view it strictly as answer getting. And I want to argue it is that much more rich, broad view of what mathematics is. It does involve getting the correct answer. I mean, there is only one answer to 245 plus 98, but there may be lots of ways we can get it. There is only one way, the one correct answer to solving 3x plus 5 equals 22, but there's many ways we can get there. And I want my students to have that understanding. I want them to be able to solve. I want them to be able to take that math and apply it to the world around them, not just find the correct answer to a problem. That is a part of that. So when I think about what is mathematics, it really boils down to opportunity. And this word has resonated with me a lot lately. I really want to do, what am I looking at? What am I doing for my students? What am I doing for the students that I'm working with, their teachers? How are we increasing opportunities for every single student? Mathematics can no longer be just for the few. It needs to be for each and every student. So I think about opportunity. This slide resonates with me all the time, this definition of insanity. And I think in mathematics education and in education in general, for way too often, we keep doing the same thing and we just hope that there's different results. I often like to joke that we can all think of a colleague that when they reteach something, they say it slower or maybe a little louder. And I think that's a definition of insanity. We have to be willing to look at doing things differently. Now, incidentally, I've been told recently that Albert Einstein, while he's credited with coming up with this definition, it probably wasn't him. That people other than Albert were the first ones to sort of talk about insanity in this way. And I think that's so true in mathematics education as well. So often we associate something with a person who didn't discover it. For example, Pythagoras. We think of him with the Pythagorean theorem. But Pythagoras didn't discover the Pythagorean theorem. Somebody in his secret math society may have discovered it, but it was around for centuries before him. And it's always interesting when I share that with my students, they're always like, whoa, there's a little bit of controversy in math. And I think it's important for our students to realize that so often we attribute something to somebody who really shouldn't have been the one that was attributing it to. So when I think about that definition of insanity, that really brings to mind this Catalyzing Change series from NCTM. And in 2018, we started out with a catalyzing change in high school mathematics, initiating the critical conversations. In 2020, we released a catalyzing change in middle school, as well as a catalyzing change in early childhood and elementary. And then just recently, we've released success stories with some early stories of, hey, what does it mean to effectively implement change in mathematics education? And I want to take a deeper look at that. So there are four key recommendations. This recommendation one is to broaden the purposes of learning mathematics. Recommendation two, and you can read those. So when I think about learning the broadening that recommendation or broadening the purposes of learning mathematics, that involves so much different stuff. But I really want to hone in on this recommendation number two, this creating equitable structures in mathematics. For too long, we have sorted our students, whether we call it ability grouping in the elementary school, whether we call it tracking in the middle school and high school, but for way too often, we have created these inequitable structures. And the time is way past now to take a good hard look at reducing the number of tracks that we offer in our schools and to look at other alternatives to tracking. Let's have things that actually meet the students' needs. So when I think about why is tracking such a hideous thing, that ability grouping, it's really based on perceived ability. And too often, my perceptions as a teacher are not always accurate. Ability grouping is really perpetuating privilege for a few, and it's marginalizing so many students. And the worst thing about tracking is depending on what track you get, the mathematics is taught completely and totally differently. Oftentimes, for those who have been perceived to be strong in mathematics, we put them in a track wherein we call a high track, an advanced track, or whatever. And we think back to that, what is mathematics that I asked at the beginning? Too often, the tracking, those advanced math students, they receive the mathematics that's focused on problem solving, on reasoning, on sense making, on applying. But those in a lower track, especially if we have a remedial track, they're taught mathematics as answer getting. And we're limiting opportunities. We're not providing our students then with the opportunity to make sense of the mathematics, to reason through. And I would argue when we get to that understanding stage, all of a sudden students start to see why it's important to learn mathematics. And they're that much more willing to continue to learn mathematics. So I urge us to think about what are those systemic barriers in place in our districts, in our buildings, in our classrooms. If I do some ability grouping in my classrooms, are my ability groups, is there some flexibility? Or if you're just happen to have done well with fractions, you're put in that high ability group and you're in there forever. And we know that there's so many different areas of mathematics. And a student may currently excel in one area of mathematics, but yet may struggle in a different area of mathematics. And we also know when we think about tracking, it really comes along racial and socioeconomic lines that way too often, for way too many years, students of poverty, our Black and Brown students, are way too often put in those low track courses, and their opportunities are greatly limited. And if we want to think about what can we do to better meet the needs of our students, it's teaching math by understanding, getting them to reason, to sense make. And that happens when we take down all those tracks, take down those ability groups. But I would argue those four different recommendations, they're really all intertwined. We honed in for a little bit on those creating equitable structures in math. I want to go back to that first one for a brief moment, broadening the purposes of learning mathematics. Mathematics should not be just for getting a better job. That is a part of learning mathematics. And I think in the past, when we thought about why do we want our students taking mathematics, it's so they can get a better job. There is more to mathematics than just that career preparation and those financial implications. It's more than just national security. I want my students to reason, to make sense of the world around them. I want them to see how math is applicable to a variety of different things. And because I want to do that, we need to continue looking at how much data are we doing, how much probability, how much data science. Think back to the pandemic. There was so much going on there, so much data being shared. I want students who can reason through that data and start to identify the bias. We're going to look at that third recommendation in just a moment, the implementing equitable math instruction. There's also this notion of developing deep mathematical understanding. And that really ties in with the rest of them. We want our students to have it math by understanding. We want our students to have a common shared experience through at least those first 2 years of high school, and then offer a variety of pathways based on those student needs. And it's through a combination of all four of these recommendations and through having conversations at your local, your district, your state, that we can truly implement change in mathematics and truly start to better meet the needs of every single student and increase those opportunities. So I think about the effective teaching practices. For the past 10 years, NCTM has had this wonderful document called Principles to Actions. And in there, we lay out 8 effective mathematics teaching practices. And for many of us, these are not new. For many of us, we have seen these. But I like this representation of the 8 much more. And this representation of the 8 really says, hey, it boils down to 3 things. That first thing, we need to establish a mathematics goal to focus our learning. And I would argue, too often we put that mathematical goal at the beginning of class on the board and have the students copy it down. A waste of time. We're destroying the ability for our students to start to make sense because too often we just tell them at the beginning, here's what you're going to discover. No, if we need to have a mathematical goal on our board, let's make it broad. And then at the end of the class, we can add it with a little bit more specificity and ask our students then, have you discovered what we wanted you to discover? Have you started to make sense of what we really truly need to make sense with? And I would argue that mathematical goal is really more for me as an educator. I need to know, where do I want my students to end up at the end of the time? The second thing that this arrangement of 8 effective teaching practices is telling me is, hey, choose your problem, choose your task wisely. Are we focusing more on the problem solving, the reasoning, the sense making? Or are we focused more on building some procedural fluency from that conceptual understanding? And they are certainly not mutually exclusive. But sometimes the task that we're doing, the work that we're doing, may be more about making sense of the problem, applying it. And other times it may just be about building a little bit of procedural fluency. And then those bottom five are really saying that same thing. We need to get our students talking in mathematics in order for them to make a good, solid understanding of the mathematics. Now, let me be clear. My middle school students very rarely have difficulties talking in math class, but getting them to talk about the math in math class is the challenging part. And we need to not give up when our students start going off topic or start talking about other things. That's human nature. Think about in a staff meeting, think about in other spots how often you get off task with things. We need to put structures in place to get our students back to focusing on that good, rich problem solving, that good, rich discussion. And when our students are talking about math, they're starting to make sense of that mathematics. And I think as a broad mathematics education community, we started to make some good work on that. And then the pandemic hit, and mathematics education changed tremendously. At least it did in my classroom. And I'm thinking back to 2020. I still remember that March Friday when we got an email from our superintendent saying, hey, we're going to shut down for the next 2 weeks. We'll have our spring break on that third week, and then the world will be back to normal. I still remember the cheers from the middle school students when they heard it at the end of the day. And we quickly realized the world is not coming back to normal in those 3 weeks. In my district, we made the decision for that April and May and maybe that first week of June, because internet connectivity at that point in time was an issue for many in our district. We made the decision there's going to be no synchronous classes. Everything is all asynchronous. So my class changed from some of that good, rich problem solving to much more, hey, here's a short little video that you can watch of me telling you exactly what to do step by step. And because I know that most of you aren't going to watch that video, I've also put step-by-step directions in Google Classroom as a PDF so you can just download it. And hey, here are 3 problems for you to do that all you have to do is just plug and play. Take these new numbers, replace the numbers on those notes, and poof, you'll get the magical answer. And if you did everything correctly, if you entered everything correctly into the Google form I provided for you, poof, you'll get a little bit of instant feedback. And I know my story is not unique. For many of us, that's how we changed our teaching. And it is through the fault of absolutely none of us. Hear me carefully, it is not through the fault of teachers that we had to change how we teach. And we did the best with what we had. And then we saw results of test scores. And the scores plummeted, which was not a surprise to many. Maybe the level of drop surprised some, but that the test scores dropped should not have been a surprise to anybody. And that reinforces for me the way that I taught during the pandemic, again, through no fault of anybody. The way that many of my colleagues taught, again, through the fault of nobody, was not an effective way of teaching our students mathematics. Teaching them math as purely procedural, as purely memorize these steps or follow these steps and put in new numbers, that did not work for our students. We need to reinvigorate our mathematics classrooms. We need to make sure we're going back to that rich problem solving, that deep mathematical understanding, pushing our students to get to that point and stage, and getting our students talking about the mathematics in math class to develop that good, solid understanding. And I am confident, as I work with mathematics teachers throughout our nation, I am confident that when we continue to focus on that problem solving, continue to focus on making sense, continue to focus on that rich mathematical discourse, that good things will start to happen for our students and opportunities will be increased for our students again. And it's all about those opportunities. When our students are talking, they're engaged. When they're engaged, they have more opportunities to be successful in mathematics. So I'm going to pause here again for a moment, and I want you to think of the first 3 words that pop in your head when you hear the word struggle. For many of us, at least for the teachers that I've worked with throughout the nation, things like difficult, tears, frustration, hard, mathematics sometimes gets thrown out there. Those are all things that we think of sometimes when we think of struggle. We often associate struggle with negative in nature. And I want to argue that struggle is a necessary part of learning mathematics. When we think back to those 8 effective teaching practices, one of those was supporting that productive struggle. But I want to step out of the mathematics education world for a moment. I want to think about learning to ride a bike. There's definitely struggle involved with learning to ride a bike, and we value that struggle. We recognize it's through that struggle that they truly learn to ride a bike. In fact, we value that struggle so much, we provided a scaffold. Now, we don't call it a scaffold, we call it training wheels. But really, that's what it is. It's a scaffold. Our ultimate goal is not that that child is able to ride the bike with training wheels. Our ultimate goal is that the child is able to ride the bike. And I think about that in mathematics education. If I think about use of manipulatives, for example, my ultimate goal is not that that child can add integers in a middle school, in a high school using algebra tiles or using two-color counters. My ultimate goal is that they're able to add integers. I think about learning to swim. There's definitely struggle involved with learning to swim. And as a society, we value that struggle. We recognize it's through that struggle that somebody truly learns to swim. If I think about that role of that swim instructor, I'm often reminded that swim instructor is not doing all of the work. It's not like the swim instructor has grabbed the child's arms and started propelling them through the water, or grabbing the child's legs and started fluttering them. No, the swim instructor is there to say, I believe in you. You know what to do. I'm here to make sure that you don't drown. But I wonder how often I am not like that swim instructor in my classroom. I wonder how often I am doing all the intellectual work and my students are sort of along for a free ride. So whether we're learning to swim, learning to drive, learning a new dance move, learning a new instrument, learning a new sport, learning whatever, in society we value that struggle. And we recognize it's through that struggle that we truly learn. And yet, way too often, for way too long, that struggle comes to a grinding halt in the mathematics classroom. And mathematics is taught as here's step 1, here's step 2, here's step 3. Just memorize those steps and you'll be fine. No, let's remove that. Let's find that time and that place for that. Let's get them to start to make sense. And then we can provide some of those more step-by-step directions if we need to. But at that point, it's more of a consolidating their thinking. It's to try to formalize what they've started to make sense of already. But when I think about this notion of struggle and productive struggle, it's not like when I go into a math classroom and everybody's in tears and I'm like, oh, way to go, there's a great classroom. No. Here is sort of the description of the productive struggle that I'm talking about. And you see those words that pop out to me. I'm reminded my job as an educator, our job as educators, whether we're in the classroom, whether we're in a building and we're supporting the teachers in there, whether we're at a district level, whether we're at a state level, we need to be providing those opportunities for our students, those supports for our students to engage in those mathematical concepts and for them to grapple. And I love that word grapple and what it implies. I want my students to leave math class feeling a little mentally fatigued. I don't want to just be me as the teacher who's mentally fatigued. I want my students to be grappling with those ideas, those relationships, trying to make connections, seeing how one thing is related to another thing, because then they start to make sense and they're increasing opportunities and they start to gain confidence with things. So I want to illustrate this with a couple of different examples for a moment. I talked about earlier about that 245 plus 98 and that there is only one answer. I want you to think about how would you go about finding that answer to 245 plus 98. For some of us, we may do 245 plus 100 minus 2. For some of us, we may have thought of it as, oh, let's steal 2 from 245 and give it to 98, where it's 243 plus 100. Some of us might have done 250 plus 100, subtract off 5, subtract off 2. Some of us might have imagined putting the 98 under that 245 and doing that good old traditional algorithm. But here's my point. For many of us as adults, we didn't jump straight to that traditional algorithm. We reasoned through, we made sense of that problem. And yet, in way too many classrooms, we tell our students that thou must do it this way. Let's allow our students that flexibility to think. It shouldn't be just when they're adult that they're allowed to think. Perhaps we do an agree or disagree. I could give that problem on the left, the solve 4 times a 3x plus 2 equals 56 to my students, and I know that most of them are going to solve it using the distributive property. But if I want to introduce another way, at least in my class, if I say, hey, great job, you all did the problem correctly using the distributive property, let me show you another way, for so many of the students, that's ticket for them to tune out. But what about if I do this green method? What if I said, hey, Camden says, here's another way you can do it. Is Camden correct? And Camden is not a student I had that year because then everybody turns to Camden and said, really, Camden, this is how you did it? I want my students to start to make sense. So I can use this strategy when I want them to make sense of an alternate strategy rather than me just telling them. But I have to be careful. I have to make sure that I choose some no's. If the only time I ask that question is if the answer is yes, they start to say yes every single time. So pull out that common error and say, hey, what do you think of Carrie's method? Did Carrie do it correctly? Let's put some of that onus of responsibility on our students. Let's get our students deeply thinking, and then let's have that rich dialogue. Too often, we do all the thinking, we do all the telling, and our students are along for that free ride. Let's get them mentally engaged. And I would argue when we have them do things like that, when we have them do that agreeing, disagreeing, when we allow them that flexibility to think through how would you figure out 245 plus 98 or whatever our problem is, we're increasing those opportunities for our students to be successful. And when our students start to feel successful, they want to continue in this wonderful world of mathematics. And it really, another word for these increasing opportunities and why I want them to feel successful, it's really about this notion of identity. And I love this definition here from the impact of identity in K-8 mathematics. Now, don't let the title think, oh, I'm a 9th through 12. This doesn't apply to me. It applies to you full force. The classroom vignettes, the descriptions I use are just from the K-8 world, but the ideas apply just as well to 9th through 12th and beyond. And you see, it's that disposition, it's that deeply held belief that students have, that people have about their ability to participate, perform in mathematics. And I would argue a student who has a positive mathematical identity is much more likely to want to continue on in mathematics and will continue to have success in mathematics. But why is identity such an important thing? Those 5 equitable teaching practices, one of those was focusing on identity. When I think about the equitable teaching practices, and there was a group of mathematics education researchers that looked at it, you see one of them there is positioning our students as capable. But how do I find out what my students are thinking? Maybe part of it is exposing them to a variety of different mathematicians, not just the traditional old, dead, white mathematicians. Let's expose them to a variety of other mathematicians. And if you're saying, hey, I want to have some other ideas there, Annie Perkins from I think she's in the Minnesota area, has a great website. If you just Google not just white dude mathematicians, she provides a wide range of different mathematicians to be able to begin to have those conversations. So every week at the beginning of the week, I have a 3 to 4 minute little presentation about a different mathematician. Many of these that you saw on the screen are ones that I use. I do still use the traditional, historically rich ones, but I focus on ones from a variety of different cultures so they can see themselves. I try to find people who have done something recently because for so many students, they view math as something that was done decades and centuries ago. And they're here just to relearn those things. And I want to expose my students to that math is still being discovered. And it's been discovered by people who don't just look like me. When we think about adding integers, too often we've just told them, here is how you add the integers, and then we allow them to start to think. What about if we transition how we do it? What about if instead we had them first use some algebra tiles? After they've used some algebra tiles, then have them do some drawings of those. After they've done some drawings with it, then turn to your neighbor and talk about how would you figure out 100 plus negative 101. And then at the end, maybe we allow them to take some more step by step notes. But I think traditionally, we started out with those step by step notes for whatever topic. I just illustrated here very, very briefly with adding integers. We've given those step by step notes and then said, now let's think. Now let's have them start to reason, start to make some sense. And then through some rich dialogue at the end, we can take some more of those traditional looking notes if we feel the need to. Or we have our students write some notes for them to do some summarizing. So, sort of flipping the direction that we may have done things in the past. So, my call to action to you, what are you doing to increase opportunities for every single student? It's past time for us to continually consider what are those structures that we have in place? What are those teaching practices that we're using? Are they truly effective in meeting the needs of every single one of our students? I provided my contact information here. If you have questions, let's dialogue through there. Let's reach out. Let's make connections. And I'm happy to help support you in whatever way. And again, thank you for being part of the world's greatest profession, being a mathematics teacher, working with students and helping them develop a good, solid understanding of mathematics. And I wish you a wonderful school year. Thank you.